previous class, we saw the Java language keywords, and then we saw the naming rules and conventions for identifiers. We spoke briefly about data types. We then looked at the building blocks of a program like variables, methods, and objects. And then we talked about objects and classes, the arithmetic operators, increment or decrement operators, relational operators, equality operators, logical operators, short circuit operators. So basically, some of these are done, some of these are to be done in the class today. The ternary operator, the assignment operator, typecasting, selection statements, iteration statements, and transfer statements. So we saw like an example or example of the variables, the constants, the operators, and we discussed what is an expression, what is the difference between an expression and a statement, what are conditionals. We briefly discussed the overview of loop, what is a loop, and what methods are. And then we spoke about the primitive data types. So primitive data types are the data types, the basic data types, the building blocks of your programs, and the building blocks for other complex data types. So when I say building blocks of other complex data types, is basically what I mean is that you can create a data type which could be a class, and that class would be made up of primitive data types. So when I say, like, when I create a person class, the person class represents the data about a person. So in that class, I can have the data types like name, which is a string. So the data type of this name is a string, so that's a primitive data type. Then that person can have its age, and that age is again a primitive data type, and so on. So these are like the basic building blocks of your normal programs and of other complex data types. So we already saw we already talked about the basic types like long, float, boolean, double, character, and then basically integer, and so on. Now we also saw the default values of like some of the primitive data types. For example, a byte will always have a 0, a short will have 0, integer will have 0, long will have 0, which is followed by a suffix L. L is nothing but just like a literal. So 0L is a literal to represent that this is a long value. The same way you have 0.0 for a float value, which is a floating point single precision number. And then you have a double, which is a double precision floating point number. We have this character, which is char, and the default value for this is Unicode character 0, which represents nothing character, so basically. And then we have string, which is a normal object, or like a string is a value type. And we'll talk a little bit about reference types and value types, but that's like during the later phase of the basics of Java. And then finally we have this boolean, which is by default false. So a boolean can store either true or a false value, and the default value for boolean is false. So we already saw the conventions for naming them. So generally people don't use dollar signs. They don't start it with a number. You cannot even start it with a number, and you don't start it with a dollar sign or an underscore character. The general condition, or there are two ways of naming things. One of them is called the Pascal case. The other one is called the camel case. So in camel case, you have the first letter or the character in lowercase, and then every other character, the first character of every other word is a uppercase. So just to give you an example, maybe you guys can see my screen all right?
Yep.
Okay. Let's share a whiteboard somewhere. Okay. So what I'll do is basically I will say, like, for camel case it will be something like, let's say if I want to write my name, the camel case would be like this. I'll stop sharing it here and I'll start a new whiteboard. So the camel case for my name would be like this. This is the camel case. I'll just, okay. The other one is, and this one is called the Pascal case. So these are two cases that people generally use for what do you call it? Naming the variables and other type of objects in your program. And
Steve, I don't see anything on the whiteboard.
Yeah.
If you don't see anything on the whiteboard,
No, it's blank.
can you see something now?
Yeah.
Yes.
Okay. So basically, what happens is, like, until as long as I'm typing, it's not visible. But as soon as I change the tool, it gets visible. Okay, I wasn't familiar with that. All right. So this is the Pascal case and the camel case distinction, and generally people use both these to name their entities, and it depends on the convention. So basically, when you have a Pascal case, it's generally used for the fields and properties which are public, and the camel case is
I can see it now.
Okay. All right. And the camel case is used for method names or the name of the functions or methods that you create in the program. So that's the general convention that we see across Java. All right. You cannot have spaces between the names of the variables. Okay. So we spoke about operators. So operators are like the special symbols which do something. Generally, operators are not just limited to symbols. They can be words as well. But for the initial discussion, to keep it simple, the operators are symbols which operate on some data. So the operators are of two types, which is binary, the other one is unary, and so that's depending on the number of operands that they can operate upon. So if it can operate on two operands, it's called a binary operator. If it's working only on a single operand, it's called a unary operator. So we saw all these operators in example: plus, minus, multiplication, division, and remainder, or the modulus operator. We saw equality and relational operators, which are used to compare things. So greater than, less than, equal to, less than, equal to, greater than, equal to, so on. And then we have the conditional operators, which are like the operators for doing conditions or adding conditions. So we'll start looking from here. We'll just continue with the conditional operators. So what conditional operators do is basically they are mostly used for testing against certain conditions. So for example, here if I say that this is a condition, I is less than 32, so I'm checking, and this particular statement will return a true or a false. So we saw the example the other day where we were doing comparison, or like we created some of the basic programs, program to do some of these basic arithmetic operators, and then bitwise operators for doing um, some simple addition, multiplication, and changing the values of a number using the bitwise operators. Now, in the class today, what we are going to do is basically we'll just go back and look at the primitive data types. So basically, if you see here on my screen, I'll just first of all make this as well smaller. Okay, now we have this, and this is like a simple example of the primitive data types. We have got Boolean. This is how you create a Boolean value, and then you assign some value to it. So you can do the initialization and declaration together. So here we are declaring the result and also initializing it with a value or assigning it with a value of true. And then we like all these are the primitive types that you can see here, right? So this is how you create the basic primitive types. The idea is to just make you familiar with how and like what kind of keywords do we use. So here this is a decimal value. So in the number 26 in decimal, the number can also be written in hexadecimal, which is this notation. So an integer can have a hexadecimal value or a what do you call it, a decimal value, and you can even use binary values. So this is a binary value if you see here. So it's integer, and then it's having a binary value, the representation of number 26. Now we have got an example of like floating point literal. So you can have double like this, you can have double like this. This is the scientific notation, as you are already familiar with, and this is the floating point notation. So it's a floating point number. And then here I'm creating some output message into the console using the Unicode characters for a string. So it's like a Unicode representation of those characters. So, and this is like another one, which is this one, this number. It prints this statement. It prints C senior, which is like yes sir. So basically, what we are trying to do is basically we are trying to, because if you see these are Unicode characters. I don't know if you are able to see it clearly or not, but if you see here, this C, it has S and then I with an accent, and the same way this we have this N with an accent. So these are Unicode characters. These are not ASCII characters. So we use Unicode to represent them. And then there are certain other special characters like backspace, which is like one space back of whatever you type. Then we have this tab, the line feed, which is like a new line, the form feed, which is like a form. It's a variant of a new line. Carriage return, that's another variant of new line. When you have to create double quotes inside a string, you escape it. So escape it with a backslash. So all this is called escaping. Escaping means that, because let's say, how do you create strings? I'll just give you an example here. So how do you create strings? So I'll say string A equals to, I create string like this. So strings are enclosed in double quotation marks. But let's say I want to enclose something inside a double quotation mark in the string itself. So I'd say I just want to write my name is the, and then I want to have something like this, big guy. But I cannot do that because the compiler looks as the quotation marks as the boundary of the string, so starting and end point of. So what I can do is basically I can escape it with a backslash like this, okay, and then like this, and then now this is like a string wherein the big guy will be in the the double quotation marks. These are some other variants of primitive data types like long. So if you want to have, you can have a long number, wherein like this underscore. If you look at this underscore, this is like a way of, formatting your or making it more readable for us. So we generally have this habit of like reading numbers like this. So if I want to say 5 million, I will say something like this. Sorry. Right? So this is how I'll say 5 million. But like for us to be able to represent, to have the same kind of key, what we can do is we can separate the different digits with a underscore, and that way like we can have a good representation of those numbers, or in terms of readability. So if you see here, we have got different kind of notations. We have got hexadecimal, we have got hexadecimal words, or hex words, what we call them, which are like so hex words are nothing but like hexadecimal numbers, but they are separated like four characters at a time. Now what 4 characters means is like one hexadecimal digit is like 16, and the value of like 16, in order to represent that, is like you create what do you call it, this is 1 byte in itself. So that's what it means to have so this is 1 byte, this is 1 byte, I think, and so on. So you can have like hexadecimal words like this. Then you can have something like this, which is another way, the same way, where we are separating the various place values using underscores to make it more readable. This is another binary representation, and this is another one, wherein like we are separating each byte by an underscore to make it more readable. So what compiler does is simply ignores these. So that's another example of like of how you create the primitive data types. Now we'll talk briefly about the control flow of a program. So what I mean by control flow is basically how your program control flows. So as always, your program always starts with the main, and then it moves on to any other functions. We'll look at these functions and the things like switch and those kind of things after we have discussed the branching. But here I just wanted to demonstrate that you start with your main function, and then the main function starts off the program by calling other functions in the program, or you can have all your logic written in your main function as well. There's nobody stopping you from doing that. But as I said, in order to make it more maintainable, it's always advised that you separate each unit based on its work. So you could, for example, you want to have a function, or you want to write a program that sends out emails. So ideally what should happen is, like, in order for you to send emails, basically first step would be to get a list of customers to whom you want to send the email. So that's like the first step. So you can get you can create a function, a single function that returns that list. And in the next step, you want to determine the context for each individual customer that gets returned from that list. So you take one customer at a time. You then create another function, then to which you can pass the customer ID, and that customer identifier can be then queried against the database to find out what kind of email needs to go out to that customer, and so on. And then once you have that content, there could be another function that does take the email ID and the content and sends it to an email ID. So basically that way you can modularize your program and then it's more maintainable. So basically you can reuse the same function again and again, because what you need to do is basically you just need to pass it the email ID and the content, and the function is general, so it can be used not just in the current program but in any other program that you might write later on. And finally, we'll talk about a little bit about the branching. So what is branching? So basically, branching is nothing but a way of uh, uh, making decisions in your program. So how you make decision is basically by using certain statements. Some of those statements are like if. So you write if and then else. So what if means is like if a certain condition is true, then it goes inside that branch. If not, then it goes inside the else branch. So you can have if, let's say if my name is Pradeep, I'm a good boy. If my name is, or like if my name is Pradeep, I'm a good boy. Else, I'm also a good boy. So that's the general thing. But yeah, um, the thing is, when you write programs which are like doing some real work, you have to make those decisions, right? So in order for you to be able to have that kind of logic, there are if statements, which is like they help you in writing code which can make decisions. And second kind of statements that we look are the loops. So loops are something which do some option or something repetitively. So for example, we have got this for loop. So what it starts with a counter of I, which is an integer value here, and the initial value of I is 0. It goes on to doing something until this condition is met. Now what this condition is, that while the I is less than the length of the array that we have, so we have an array of integers and it goes on until this array of like I is less than the array of integers. We start with the initial value of 0, and then with every iteration we increment the value of I by 1. So this is what we call it, a postfix increment operator. What this does is basically it increments the value of I after this loop has executed. So this is why it's called postfix. It increments the value afterwards, after one iteration. There is another variant of the same which is called plus plus I, or it's called a postfix increment operator. What it does is basically it increments the value of I uh, before the loop executes. So we start with 0, and before the first iteration the value of I becomes 1, and then it goes on increasing. So that's the postfix or prefix increment operators that we saw right now. And this is also known as, this particular thing is also known as the invariant of a loop. What it means is that it will make sure that the loop terminates. If we don't do that, this loop will go on forever. But that's not like it'll keep on printing the same number again and again, or doing the same stuff that is inside this code, inside the loop again and again. We don't want that to happen. So what we want to do is basically we just want to uh, terminate the loop as soon as our job is done. Okay, so this is our branching, and we'll now move back to the control flow, because as I said, like we'll discuss about the control flow. And the control flow is like another thing which is related to your branching. Why is it related to your branching? Is because in the control flow we first make decisions. So we make decisions wherein we use if and then. So if number is divisible by 2, because we are saying the number divided by 2 equals to 0. So this is the percentage division operator, which means that this is an even number, right? So, and another thing to notice here is that when you are using this if statement, if something that follows the if statement is just one liner, or like it's single statement, you don't need to have the starting and the ending curly braces, or this opening and closing curly braces. Don't need that. However, if it's more than one statement, then yes, you need to define that boundary for the compiler so that it can know like where your condition ends. Now we have got this if then else example, wherein like if number if number is divisible by 2, we write the number is even, otherwise we write the number is odd, right? Then another kind of if else statements are like if and then else if, else if, else if, else if. So these are like, so first of all we'll check for this condition. If this is true, then the next statement will be executed, which is this one. If this is not true, then we'll go and check another condition. So this is like let's say if you want to calculate a grade of a student, whether it's A, B, or C, so that would depend on his marks, right? The number of the percentage that they have scored in the examination. So here, let's say if the score is 86.45, what would be the grade of the student? Given the condition that like for those who score more than 90%, their grade would be A. Those who score more than 85% and less than 90%, their grade would be B. Sorry, A. Those who score more than 95% would be A plus, and then those who score between 85 to 75%, their grade would be B plus. Those between 75 to 70% would be B. Those between 70 and 60 would be C plus, and those between 60 and 55 would be C. Those between 55 and 45 would be D plus, and those between 45 and 40 would be D. So on. So if we want to create this kind of logic, we can start off with the topmost condition, or we can start with the any of the conditions on any of the sides. So what I mean by any of the sides is like on any of the extremes. So on one extreme we have the maximum value, on the other extreme we have the lowest value. So we can even start this loop by saying that if score is less than 33%, now we are using the greater than, then we'll use the less than sign. Less than 33%, then the grade is E, or sorry, F. So it's going to be F. And when the score is I'm sorry. So yeah, if the grade is if the score is less than 33%, I'll just start a whiteboard. That way it's bad, rather than going it verbally. So if score is greater than less than 33%, the grade is F. If the score is greater than 33, E. Now here we have to use a compound statement. What do you mean by compound statement? If the score is greater than 33 and what was the next count? Okay, and score is less than 40. So this is like a compound condition. We have got score is greater than 33 and less than 40. The condition would be, or the score would be E, or the grade would be E. So like you can do this kind of logic as well, or you can have the logic like this, which is like plain and simple straightforward logic, wherein we start off with the highest value, and then we go on checking it for the lowest values, and finally based on whatever value we have, we just define the grade of that student. There is another special kind of a branching statement which is called switch. So switch and case, it's generally called in conjunction, which is known as a switch case. What it means is that you apply a switch on something. So a switch is like a comparison. So here we are applying a switch on this month value, And then what we are doing is basically we are just comparing, we are defining the cases. So if let's say the value of month is 1, so we call it case 1, and then so this one is the value, it's not the numeric one. So okay, 1 case, 2 case, it means that what the value of month is equal to 1, then the month string becomes January. If the value of month is 2, the month string becomes February. So it's more cleaner than writing if-else statements like this, because you can define what is the value of each particular what is the value of month string in case of each particular value of month, and that's way it looks more cleaner. And you can also have a default value, which means that if any of these conditions are not met, then we'll say that the month string would be invalid month, and so on. Right, so this is an example of using switch for doing the same kind of branching. And then finally we are using like another example wherein we are using the fall through example. What it means is that we use all the, what do you call it, all the values based on the value of the month, we add them to this collection. If you don't understand about this collection like array list and those kind of things, don't worry, we'll cover them about in the future. But right now the idea is that we just want to ask the user what month it is, and or based on this month value we add it the name of that particular month to the collection of the strings that we have created. So it's a collection of strings, and we just add it to that particular bag that we have created. Now if I want to run this program, what I can do is basically I can just call this function here from my main method. Right. And if I run this, yeah, so here we have got this example which says, first of all, this is an even number. This is based on the check. So if we divide 10 by 2, the remainder is 0, and that's the condition for being an even number. Other is like the number is odd when we divide it by 2, and like the remainder is not 0, so the number is supposed to be an odd, which is for 15. So we are checking this for 15, and then we are checking the grade, which is like for the marks that the student has scored. So here they have scored 86.45. If I make it 96.45 and run the program again, now the grade becomes A plus. And if I make it my actual grades, which is 36, so the grade is E. So yeah, as you can see, like these are the if-else conditions. You could have done the similar kind of condition uh, with the lower bound, wherein you start from the 33 and then you go all the way up to 90. The choice is yours. There are different ways of writing the same logic, and I prefer writing it this way because I start from the highest value possible and then go down, and then in that case I don't have to do this compound conditioning where I do this, you know, and or. By the way, like I already demonstrated what and. Uh, Sorry guys, there is some I missed to share my screen. I'll just do it right away. So yeah, so this is the example that I'm talking about, or here we have got this number which is like the number that we are checking for being an even or odd, and then we have this score, which we saw here. Another kind of statement that we spoke about is the switch. So here we have this switch statement, which has got various cases. So we are switching on the value month. So month value is the switch that we are using, and based on the value of the month, for example, if the value of the month is 1, we use the string as January and so on. So basically we are trying to come up with the month names using the switch statement, and every case follows with a break statement. What break statement does is basically it just breaks the control out of this, because switch don't start and end with the set of curly braces like other conditionals do. Like here you have this curly braces, so we don't have that in each condition here. So we indicate the break as by using this break statement, so that the control can fall through out of the switch condition. So I was just demonstrating this example. So we are using this to do the to perform certain basic checks and conditions. So here let's say if I change the month to 10, it should automatically calculate the right name of the month. So if I run it again, so now the month becomes October. And if I make it 15, which is not a month anyways, so it will just say invalid month. So this is like your branching statements on your control flow. Finally, we'll talk about loops. Okay, so what loops are? Loops are like doing certain things in repetition. So for example, the most simplest loop is the while loop. What it has just a condition, and it goes on doing that job until it's done, like that condition is true. So for example, if I want to start writing all the numbers from 1 to 11, what I'll do is basically I'll say while count is less than 11, and I'll just keep incrementing the count on every iteration. So I'll say count plus plus, and if I run this program, so that's the first statement. Let's see here. So yeah, I start from here and it goes on until 10. Sorry, it goes on until 10. So this is our normal while loop. I can also have an infinite loop. What this infinite loop does is basically, I'll just show you. Somebody has their TV on. Can you please either uh, Susan? Okay. I'm not sure who is like who's having these is either Sonia or Susan, because I see like Sonia. I can see Susan twice. Uh, Anyways, so guys, please, like it will be really helpful if you can please either mute your microphones, or if you have any electronic gadgets running, uh, please mute your microphone, so that like we don't have this background noise coming in. Especially it's like it's there in the recording as well. So when you'll get the recording as well, you'll see that it's there. And like when you have to speak, it distracts to hear. Yeah, so it distracts, and then that becomes a little bit problem. So anyways, so this is uh, what do you call it, the infinite loop. So what we mean by an infinite loop is like something which keeps on running forever. So here this statement will run forever. because the invariant of this loop is while true, and what that means is that it will keep on running forever. Count is less than 0, break. So this is just what do you call it, workaround to make the compilation warning go away, saying that the compiler now thinks, okay, we are breaking out of this loop. Otherwise we were getting an infinite loop error earlier saying that this will go on forever. But I just want to demonstrate, like, if I don't have an invariant, we'll have this this repeating forever. So I'll run this application, and yes, so it will keep running forever. Why it keeps running forever is because we are not terminating the loop anywhere. So when you write programs, you have to be careful that you terminate your loops with proper conditions or invariants so that they don't keep running forever. There is another example wherein, like, we have this do while loop. So do while is like another extension of do loop, or while loop. What it does is basically it executes at least once. So this loop might not execute once. Let's say if I'm saying count is less than 11, so I make the value of count 12 or 11 itself. 11 is equal to 11, not less than 11. So I'll say if the count is this loop will not execute even once. But here this loop will execute at least once this piece, and then it goes and check the condition, and if that condition is true, it goes again to execute it. If that condition is false, it just doesn't execute it anymore. So the difference between a do and a do while is that a while will execute only when the condition is true, whereas a do while loop will execute at least once even if the condition is not true. So that's the distinction. The next kind of loop that we have is a for loop. Now, what is a for loop? A for loop is like a specialized loop. It starts by initializing the counter here. So I have this declaration of the counter here in the loop declaration itself. So I say for int equals to int I equals to 1. So I initialize I with the value of 1. There are three segments in it. The next segment is the upper bound of the loop, or where do we want to go. So I'll say that while, so I start with I is less than 11, which means that the I is going to be, I execute this statement until I is less than 11, and then after every iteration, increment the value by 1. So this is like putting all these statements in the one. If you see here, we are doing the same thing with this while loop, but with while loop we have to use 3 lines to do the same thing. First thing, initialize, then check the condition, and then increment the value. But here all of this is done in a single line, and so this is like a specialized or a loop which gives you more precise and verbose more precise syntax, and is more expressive in terms of the things that it's doing. You can have an infinite for loop like this, as we did with the while. So the while infinite is something like this. A for infinite is something like this. A for infinite loop is without any conditions. So you don't start with any initialization, you don't check for any condition, and you don't do any invariance, or you don't want to you don't increment anything, and then it goes on doing or executing forever, right? So this is another variant of a variant of for loop which is going to run forever. And then finally, another kind of special loop that we see is like enhanced for loop. It's another variant of for loop, but this is more for collections. So if you have a collection, here the example of the collection is an array. So array is nothing but a collection of integer, a collection of specific data type. Our array here is an integer, so it's like an integer array, and we are initializing it with a default value of like digits from 1 to 10. Now if you see here, this is like the for loop wherein we are picking up one item at a time from the array. So we take for int item from numbers. So it's just saying that from numbers take each item and go on doing it until the all the items have been taken, and then we just print the item onto the console. So this is like just a demonstration of how do you do that using an like a enhanced for loop. So here I'm not specifying what is the length or how many times I need to do execute this code and so on. That is done automatically by the runtime. What I am just specifying is a collection and then the name for the each value that like it picks out. So the value or the variable to which it should put that value in. So take the numbers and take out one number at a time and put it in the item, and then I check or do whatever I want to do with the item in the loop body. So that's if I wanted to do something like this, I would have done something like this in a traditional for loop. I start with 0, I go and check the length of the numbers array, what is the length, and then I increment I or the counter by 1 on each iteration, and then I just print the value of that. So this is like if you see here, this is way more readable, simple, and like less error prone, because you are 100% sure that the runtime will always give you all the elements so that you don't miss anything. Sometimes what might happen is like you might write wrong logic, or you might end up doing something like this: I equals to I plus 2. So if something like this happens, it's a small typographical error. So instead of incrementing I by 1, we increment I by 2. What will happen is that we'll skip numbers from the array. So first we'll pick the element at 0 position, and then we skip the 1 altogether, and we pick the I from the second position, and then we skip the third, and we pick from the fourth position, and so on. So it's like it's a error that can happen. This is just a very trivial example, but like there could be real life scenarios where you can see something like this happening, just because of the wrong logic of fetching elements from a collection. So in order to counter that, you have this for loop, which is like an enhanced for loop specifically for collections. Okay, so having said that, I'll just take a pause. Let's go back to our PowerPoint presentation and see if like we have missed any special kind of a operator or something like that. Yeah, we have missed the instance of operator, which is like probably I have an example here. Yeah, so here we have this instance of, and I guess like we already did this in the primitive types, but just to give you an idea, we discussed that we have a parent class, a child class, and we like a child is also an instance of parent, whereas a parent is not an instance of child. So this is the rule of the object-oriented programming that we see. So here we can use the instance of operator to see if a particular object means a value, an initialized value is of a particular type or not. And that could be super useful. Let's say you have a generic program that like we have what do you call it? I'll just give you a parking facility. Now, the parking facility, when we wrote this program, we created this program on object-oriented principle designs. So we said that okay, you can park any kind of vehicle in a parking facility. We started off like this, And eventually what happened is, like, as we grew, there was like a lot of traction and people started using our parking a lot. So we started running out of space. So what we did is we started creating designated areas for different kind of vehicles. So the larger vehicles or the heavy vehicles go to parking zone A, the smaller vehicles go to parking zone B, the bikes go to parking zone C, and so on. Now we had to change our program. What we did is, like, we created subclasses of the vehicle class, wherein, like, earlier it was just a vehicle, then we created a subclass of the vehicle called it heavy vehicle, which is like a subclass of the vehicle class. Then we created another subclass which is called the light vehicle, and then we created another subclass which is called the bike vehicle, or the bike class, and it's a subclass of vehicle class. Now after doing this, like, we can check. Let's say if you are sending some, we have a function which allocates a parking space in the parking zone A. So I say park in parking zone A. So I pass a vehicle instance, although I can make the method signature such that, like, it will only accept a heavy vehicle. But let's say I just, or in order to, like, keep some sort of a scope for myself in the future, I just take a method, or like I have a parking function which takes the name of the the parking zone and the vehicle, and then allocates a parking zone to it. So what I'll do is I can just check the instance. So if I say, uh, if the type of vehicle is heavy vehicle, or if the vehicle is an instance of heavy vehicle, allocated to parking zone A. If it's a normal vehicle, allocated to parking zone B, and if it's a bike, allocated to parking zone C, and so on. So there are, like, multiple practical use cases for you to use this instance of. So instance of is like checking whether this particular object that I'm working with is of that particular type or not. We already saw the bitwise operators. So how do you do bitwise comparison, and what is bit shifting? Now this is important for us to understand. Like, operators have a precedence. So what do you mean by operator precedence is that, like, which operator, let's say if I write a complex statement, A plus plus and then B plus C multiplied by D divided by E. Now it's a complex statement. Which operator is acted upon the first? So this table, if you see here, is the the good example. Each the operator, the topmost operator have the highest precedence, and then it goes on like this. So the highest precedence in terms of arithmetic operators is the postfix, which is like, if you take, say, A plus plus or B plus plus, that has got the highest precedence. Then we have got the unary, which is like, the correct word would be postfix unary for the first one, and the second one would be prefix unary. So after we have done the postfix, the prefix is the next in terms of precedence. Then multiplicative operators. So all these operators are multiplicative. Multiplication, division, and percentage. Then we have got this additive, which is plus minus. Then we have got shifting operators. Relational operators come next. Equality operators come afterwards. The bitwise operators are below equality operators in terms of precedence. Then we have got bitwise exclusive OR, which is also known as XOR. Okay, so XOR has got a higher precedence that bitwise inclusive OR. Then we have got logical AND, the ternary operator, which is like a question mark and a colon. We'll see ternary operator later on in the course, wherein, like, or maybe we might have an example today as well, wherein, like, ternary is like an extension of the if else condition. So if I check a Boolean condition and I want to uh, branch it out in terms of the ternary, I can just I can just write If A equals to true, then the if statement or whatever I want to do in the if comes after the question mark, and the else part comes after the colon. So I can just demonstrate it with a quick example here. So what I can do is basically I can just say something like this at the beginning. I'll just demonstrate. Okay, I'll say int age of student equals to 12. Okay, and then what I can do is basically I can have a condition like this, which will do, uh, let's say, is boolean is minor, sorry, or maybe I can have just a message string message equals to age of student less than 18, and then I can say message would be you are minor. Okay, else I can say welcome, enjoy the ride. So this is like an if else condition. So if the student's age is less than 18, we just say you are a minor. Else we just say enjoy the ride, which means that, like, let's say if I have a what do you call it, a bike rental or a car rental company, and I don't want minors to take away my bikes and do some sort of a road crash or accident on the roads. So I just would have this condition in my software to not allow a minor to use the services, and then I'll just write saying that, I'll just print system dot out dot. So this is an example of this ternary operator here. You have a simple operator which uh, is a combination of two operators. It's question mark and then the colon. So two symbols together make this ternary operator, and it can be used for simple if-else conditions. Okay, and then finally the last uh, precedence is for the assignment operator. So if you want to do some sort of assignment, that comes last. So just to give you a definition of, we have already discussed this yesterday, but just to give you what do you call it, a simple definition: operators may be used in building expressions which compute values. Expressions are the core components of statements, and statements may be grouped into blocks. So this is how you just generalize this entire relationship. So you start off by creating variables, and then you use operators on those variables to create expressions. You combine expressions to make statements, and then you combine statements to make blocks, and you combine blocks to make your programs. So that's how. So an expression is a construct made of variables, operators, and method invocations which are constructed according to the syntax of the language that evaluates to a single value. So an expression always evaluates to a single value. Now that value could be a unit. A unit is a value which means that it is a void. So, but an expression always evaluates to a value. It could be a void as well, but it always does. A statement forms a complete unit of execution. And finally, a block is a group of zero or more statements between balanced braces and can be used anywhere in a single anywhere a single statement is allowed. So you can use blocks to replace a single statement as well, as long as like they follow the syntax and the rules of the language. We saw this the control flow statements. All of these fall under the control flow statements. The first one is the decision making: if then, if then else, if then else, if then else, which is like if then else if, and then then, and then finally else. And finally we have this switch, which is like uh, another way of making decisions. Another kind of like control flow statements are looping statements. So we saw all the loops: for, while, and do while. And finally, we have these branching statements which help you in branching out from the control. So for example, we discussed about the break statement. What break does is basically it breaks the control out of that particular loop. So I'll just demonstrate here. Probably I have this. Yeah, so I was demonstrating this infinite loop example, right? So if count is less than 0, break, which means that move out of this loop. Here is an example of break statement here. There is another example of the break statement which is in the switch here. So break is also used in the switch to move out of this sorry move out of this particular condition in the switch statement. Then another one example is the continue example. So continue, probably we have not seen continue as of now anywhere in this, but a continue is like when you want to skip, you don't want to exit from the loop, you just want to skip that particular thing. So let me just go and take that loops example here, right? And what I'm gonna do is basically I can just check for some condition here. If count percentage 2 equals to 0, I can simply continue. So what will happen is like nothing will happen if the number is an even number, otherwise it will just print the count. So that's another example of so it will not terminate the loop, it will just skip this particular iteration and move on with the next value, whatever is. So that's what the continue is. And then return is basically when you return something from your function. So every function has got like if it's not having a void as its return type, for example this has a void return type, so it doesn't return anything, but all other functions, for example here this get binary, it has a return type of string, and the last statement of this function is a return, or it can the return could be here as well, which means that if I return something from here, all this will not be executed, so all of this will be unreachable code. So as soon as you type return and you do something, you can just exit from the function and pass the value back to the caller. You can have a return statement in the functions which are void, something like this, but that's only to exit out of the program or of that function. So if I want to exit out of this function immediately, I'll just use the return keyword followed by a like semicolon like this, and then so if I want to say like I want to terminate it here, if I do something like this here, oh come on, so here none of this will be executed beyond this one. So if you see here, like I have this, if age of student equals to 12 and so on. Let's say if I say to make it more simpler, if I like just to confuse the compiler a little bit, I can say if, so that it doesn't think that I have a cadence equals to 0. Now the compiler is like a little bit confused. It doesn't think that I'm doing a return and all these statements. So it thinks that I'm checking for a condition and then I'm returning out of it. But if I run this program now, I start this. So it just terminated because it didn't execute any of these statements after this. So this is like the significance of return keyword. We also already saw about the if then else statements. It would be really good if you can like go through this content. It's really great content. It will help you. We have seen the practical examples, but it will also help you wrap your head around the theoretical part and any subtleties that might be associated with these statements. On the top, like from a very high level, these are okay to look and understand. But when you read more about it, you'll find that these statements are very powerful, and there are various ways of using the same statement in different kind of situations. This is all about the loop statements. We spoke about the branching statements. So that's all for today. I guess like that's all for the lesson that we did today. Uh, I would highly recommend that you go ahead and read this entire presentation material. Uh, the reason why I'm saying that is like we have seen the practical examples, and these these material that's present in this presentation is like complementary to what we have seen in the code. A and B, it's like it covers this the basics of these constructs in great detail, and also helps you in making your fundamentals strong when it comes to like understanding the basics of the language. So I would highly recommend that after this class, uh, practice or start writing some code using these, and like do some exercises. Basically, I'll also give you guys an exercise to do today, so that we can discuss it in the next class and test or evaluate. You guys can evaluate your understanding of the language and your progress yourself. So that's like what do you call it? We have this weekend coming over, so that's an assignment that you guys can access your dashboards on the training portal, right? So I'll just upload an assignment there, and then you can check it and then work it over the weekend, and then we can discuss the stuff in the next class. Okay, so that's all for today. Now we'll be taking questions for like another 5-10 minutes, and then if we'll just continue with the next class. In the next session, we'll just talk about the object-oriented programming a little bit. So if you have any questions in the class that we discussed today, please ask now. I'll keep my screen sharing open, so that I can just go back and show you or point you to the area related to your question.
Quick question. How often are we going to get assignments in this class?
Pretty often, like depending on the relevance. Sometimes, like let's say if you are just starting off with the Spring framework, and we are just building the context and doing some introduction for, let's say, a couple of classes, no assignments in those couple of classes. But as soon as we start doing some practical stuff, there will be assignments. So yes.
Okay, cool. Just wanted to double check.
Okay. Any more questions? Daniel?
I don't have any question.
Okay. So just like when this is like, I don't know, I have this strong uh, feeling that if people don't ask questions, A, you are a very good trainer, B, they are not understanding anything, which is, I'm not saying like that you guys are not understanding it. It might not be relevant, but I would really appreciate if you can ask questions, because that way it would give me the feedback about the areas which I can improve myself. For example, if I spoke about the branching statements, and if like the most of the questions that people ask were about the branching statements, then I know that okay, this is one of the areas that we can start doing better, and we can start or maybe in the next class I can just be more just look at the recording and see, okay, what was wrong with my explanation for the branching statements that led to this many questions. And then it's like a continuous feedback loop. Okay? And obviously, like sometimes I understand that like the questions, you don't have questions right at that moment, so it's okay. As you might have already seen, like we have this specific format of the class wherein we start off with questions and we end with questions. So if you uh, come back and like think that okay, I have a question from the previous class or the class day before or the class last week, that's just fine. But please don't hesitate to ask questions if you have. That's like very healthy for you guys, and that's the first step to start learning. Okay, next, Sonia, do you have any questions? Like, I just prefer to ask everybody in person so that like I get a verbal confirmation and make sure that like people are just not holding back. So,
No, I don't have any questions at this time.
okay,
Yeah,
thank you.
thank you.
Let's ask Susan. Hey, Susan.